Right, ever hungry for fame, going to do another tutorial, and what I'm going to do is actually look at the little Uno and just go around pin by pin for anybody who's still getting started, because we all did at one time, and go through and demystify as much as I can what each of the pins do, and at the same time discuss how I'm going to pre-plan the setup of this little table bot, as everybody calls them. So I'm going to start down at this. Let me just pick a pen up. I'll start down at this bottom corner, and I'm going to go around anti-clockwise, only because that seems to be the way that the pin numbering works best. So you'll notice that it's got different things against that pin, and that D0 actually relates to that first pin there, which, if you notice on this, I've copied the same smart picture over. That little 0 there is, as best as they can, lined up on the screen print to that pin there. But on this same smart, you'll also see that because they've got these three extra pins, you can actually get to the same pin from there, and they're effectively just joined together with a little piece of copper inside the board. So what you've got a situation, again, look at this same smart. If you look at the top there, you've got signal, voltage, ground, which the nice thing is that if you can literally plug a servo straight in. You can only plug the mini servos in because the other ones draw too much power, but you can literally plug it straight in, go straight into the servo commands, and it will run straight off that port. But ideally you want more power. If you want to use bigger servos, we always want to use bigger servos, bigger projects. But you can, the nice thing is you've got your ground and you've got your signal repeated every time up there, so that you end up not having to use a breadboard, which breadboards are great, but it's another level of nuisance, I would say, is the way I put it, because you've got to go from the Arduino to the breadboard, from the breadboard to your component, and it's enough of a rat's nest just coming off one of these before without adding a second set of and of course breadboards just like these, it's very easily pulled out, so very easily you transported a robot somewhere, and when you take it out, half the pins are pulled out, and you've still trying to remember where everything goes again. So, looking at the way this is laid out, right, pin 0 and pin 1 tend to be pins you can't use easily. The reason being is, as it says D1, D0, which is the way that the Arduino language looks at them. It's also TX and RX. Now, and what that is that's also the way that the programming comes in from the port up the top there. So the USB actually talks to the chip there. That's the actual chip there. Talks to that chip via those two pins. Now then, it's an advantage, a disadvantage. It means that you can actually plug in there, and you can take direct charge over the programming through little alternatives. But pin 0 and pin 1, best not to plan things in there until you've used every other pin up there, because you can sometimes interfere with the programming, and you end up having to unplug things so that you can actually program the Arduino. And these sort of sockets, they will only take so much movement before they finally give up the ghost. So you want to be able to plug and unplug as little as possible. And the little DuPont connectors, they're very fragile as well. It's amazing how sometimes one insertion is all they'll ever give you. So, try to keep all the wire movements to a minimum. So, we'll start with D2. Now, D2 is literally just a digital port. It'll either go on or off, and it's very easy in the language to actually say D2 high and D2 low. I won't go into the exact expression because we're just discussing the pins at this stage. but switching it high, switching it low is very easy. And you can literally, out of that pin there, which is there, and third one up there, third one up there, you can literally do anything from switch on a little LED right through to the, with the correct build-up voltages, you could literally switch on a power station with it. I don't think I'd want to trust a power station to an Arduino, but there's, in real terms, when it comes to the big switching systems, the Allen Bradley systems, etc., they've literally got the chips in the middle of them just like any others. It's just they've got a lot more redundancy and check systems in. You wouldn't want a power station switching on and off based on the vagaries of Arduino. Great for running what we do though, and priced accordingly. So D3, you know, it's got a little squiggle in front of D3. Now what that's telling us is, unlike the D2, you can do what's called pulse width modulation. So what that allows you to do is, you can switch it on and off, but you can also switch it on and off extremely quickly using a command. And what that does is, one of the things about electricity is, if you imagine that is, you said that's 1 second of electricity. So if you switched it off for half a second, there, and so that you've got half a second on, half a second off, at 1 second it wouldn't work. But if you're doing it quick enough, that actually will appear as half voltage. And what you do is you adjust those two sides so that you've got more on, more off, more off, more on, to be able to control the voltage without actually with a digital signal. So what you're doing is you're actually controlling your voltage that's going to a motor by literally switching on and off and controlling the amount of space that we've got where it's off to the amount of time you've got when it's on. It also allows you to send digital signals where you can actually communicate with things that are listening for that on-off Morse code type system. So ports that have got a little squiggle in front of them are quite valuable. Again, when you're designing, try to save those for things that you need, because you can literally, out of that D3, you can do anything from a pulse width modulated control right through to talking to screens, talking through to anything that's got a digital input that you can, you know, switch in a way that the two can understand each other, that they both speak at the same speed. D4 again, straightforward, digital on off. D5, D6. So once you've got past the basics of, yes, it's a pulse width modulation or it's a straight digital, then it's a bit sort of same until you start getting right through to D18. Now then, D18 is actually the same D18 that's over here, which is on this side. Now I'll come back to those as analogs. But what it does mean is D18, D19 are using what's called an I2C bus. Or they can also be analog. So if you're using them off this side of the Arduino, you tend to use them for I2C control. And the I2C control has a whole host of ready-to-go boards for doing all sorts of clever things, from being able to run time-of-flight detectors, where it's actually measuring the distance using the time that the light flies across the gap. You can right through to intelligent screens, through to great big matrices that are running using digital in-outs, etc. So from a point of view of 1819, it's a very powerful pair of pins. The disadvantage is that if you come over to this other side now, you've got all your analog ports, which is your A0, A1, A2, A3. If you start using I2C, you lose A4 and A5 because it can't be both. You know the pins it can actually you can do it. I'm arguing myself here. They want to be one purpose, because you've got one. You don't want to be constantly plugging things in and out again. So that, as I said, the problem is that on this little Uno, you lose A4 and you lose A5. So you can only have 4 analog inputs, unless you've managed to get hold of one of these little SainSmarts, which you actually, if you look on the SainSmart there, you've actually got A6 and A7. So you actually get 2 extra analog ports back. And what's happened is they just ran out of space on the early boards, because again they were using a much bigger chip in there, and a lot of the early boards were using the 328p that was almost half the size of the board, whereas now that chip up there is so small that there's room to actually get things on the board, to get the extra analogs in there. So, coming back to this side, we've got a ground. Now then, I'll mention AREF. AREF is useful if you're starting to have read problems with your analogs. And what you can find is if you've got a slightly dirty electric, or your voltage is going up and down, or particularly little batteries and whatever, which as the voltage drops on the batteries, your settings for your analog can change, so that whereas your peak voltage was say 2 volts, it starts to, as the batteries start to go, that voltage is dropping. And if you've got the threshold set fairly close, where you say above this do that, below that do the other, then you can end up having problems. So the AREF allows you to literally take your battery, plug it in there, and it will reference the voltages from that, so that it takes that as the ceiling. So that if you suddenly went down to 3.5 volts, if you put your 3.5 volts into the AREF, it would actually say anything between that and 3.5 volts is full scale, and would adjust its scale accordingly. So, useful if you want to change, if you've got mixed voltages on there. We'll come around this side, and I'm now going to go. I'm going to leave those two, IO-REF, etc. I'm going to leave those because the discussion's far deep. You just don't use them for now. Reset is useful if you've got your board embedded fairly low in and you can't get at it easily. You can run a wire off that between that and ground, and when you press the button it'll reset the processor. And occasionally you do need to be able to reset the processor. There's also that little button up there at the top which does the same job. It's effectively already across that gap, and occasionally you'll lock your processor out, you'll do something, and what you do is you then plug your USB in, but it's trying and it can't get to it because the brain's already totally occupied and not listening to that port. So basically, you press with that, you set your load program going, press that reset, and as part of the reset and the reboot of the thing, it looks at that port first before it starts running the program, and so literally you can reprogram and get yourself out of a lockout. 3.5 volts, that's an output, not an input. It's a little voltage regulator there that makes that 3.5 volts. It's useful if you do have something, but it don't pull a lot of power off them. They can't really stand it. And 5 volts is again an output, but you don't really want to be using a lot of power off these, because you can very quickly start damaging them. Now you've got your 2 grounds there. Really, they've tried to give you 2 grounds. The bottom ground on this is really your proper ground. That second ground is a ground, but it's more to do with your system ground. So if you're using ground, because you can put your voltage in on that pin, which is VIN, voltage in, you can put it in on that pin. I tend to bring everything right up to that ground, and then you're actually on your voltage ground as opposed to your processor ground. There's a lot of nuances in the differences, but stick to the bottom pin is the easy rule. And then your last ones down here are your analogues, which the nice little advantage of those is some particularly some of the newer stuff, although it's switching on and off, it's only switching on and off 3.5 volts. And occasionally on your digital side you can have problems with it seeing that, because threshold is theoretically 2.5 volts. And so sometimes you can find that it doesn't trigger and it isn't making enough voltage on things like infrareds. And when I mentioned the other day, I was using a little board that was a microwave board to look through glass, and that was only producing 3.5 volts output. So I just stuck it into the A0 and read the threshold back and said, well, anything above that is triggered, anything below that it's not triggered. We're not getting to the depth of the program, but it does mean that you can put up to 6 devices in there as long as you're not using the I2C bus. As I say, on the little SaintSmart you get the extra 2 ports there. So quickly, from a point of view of the robot, I'm probably going to go and say, right, initially I'm going to take 4 pins up for the motors, so that you've got forward back on your 2 motors. I'm probably going to go for D5, D6 and D10 and D11, partly because that allows me, I might go, I'll stick to those 2 for now. We can move them later, and I'll show you how you can do it and make the software easy, so it's easy to change your mind later. But I'm going to go for those because it also will allow us to do pulse width modulation, so that the DC motor will initially will go on, off, on, off, on, off, which is great, but it can get a bit bumpy and things bump around. Whereas if you start using pulse width modulation, you can do that lovely thing where the motor goes and you can actually ramp them up and ramp them down. And it does look really cool when the robot goes, as it goes into something, it starts slowing down as it gets nearer. And it just adds that, it's like blue LEDs, they always look good. And so we'll look at, I'm going to use those 4 ports, 4 pins for, ports I suppose, for literally for the motors. And then I'll just start at D2 up for the rest of the sensors, which, as I say, I'm going to use those little relay sensors with the long whiskers to start with, and then we'll keep it simple. We'll start out with nothing more than 2 or 3 whiskers at the front, as I call them. Well, everybody calls them, but the relays pretending to be whiskers, and we'll do a basic set of control and language from there. And then once we've got to that stage, we'll look at building and say, where can we go from there, and what else can we add? And we'll start adding sensors, and I'll take some feedback from you guys. What sensors you'd like to see running. So, quick little Arduino breakdown. I hope it helps, and we'll see where we go with the next one. If I can stop the recording. Lost my mouse.